So from complex things, now we will see something simpler. The ABCXYZ analysis and its implications. It's an analysis which we use in supply chain. And more specifically, we are going to have an introduction to the problem statement. And then we will discuss the data analysis, the data science learnings, the added value of my project, and some retrospective thoughts and summaries. So let's start from the basics. First things first, who am I? I'm someone who has working experience greater than 2 years in various positions in supply chain. I live and work abroad, and that's why I give this presentation in English because the event is recorded. So a colleague of mine maybe want to see in the future what I said here tonight and to give me feedback. And I work for GF, our Georg Fischer, and piping systems. It has 3 divisions. And my company started at 1802, so more than 200 years active. It's active in the transport of liquids and gases. It's an innovation and sustainability leader, and it has a very big portfolio of products. Now, we move to the problem statements. We have more than 120K products, so too many products, too little time. And just to quantify it a little bit, 30 seconds per product would be more than 1,000 hours. So we cannot follow the principle of equal importance. And in the end, even if we follow this principle, I'm not sure that we will add value to the company or to our customer as well. That's why we follow a Pareto approach. And the first dimension based on which we classify our products is the profits. So we have noticed that 10-20% of total products, total items, bring us 70-80% of our annual revenues, and that's why we have tight controls and high accuracy. Then we have product classified as B, which are 30% of total items. They bring us 15-20% of annual revenue, medium control, and good accuracy is necessary. And then we have the C items for which we don't spend so much time because it they bring us very few revenue. So we accept mistakes, so to say. Then we have another problem. We have 120K products. Okay, imagine how big the warehouse should be if we were having stock for all of these products, or how much money we had to spend in order to keep a stock of every product. In order to solve this issue, we take advantage of the demand variability and we classify the products as X, Y, and Z. X products have a constant demand, Y or C products have a seasonal demand, and Z products random. So in the end, combining these two classifications, we come up with this table. And for us in supply chain, it's very important to know this classification for every product because we can communicate better. We can decide if we will spend time or not. And for example, if you tell me that something is AX, it's high value constant demand, I will take it very seriously. If you tell me that it's CZ, okay, I will do it tomorrow, next week, next month, or yeah, maybe next year. And then we moved to the data analysis. What I did in order to make these classifications, I had 5 tables to connect with joins, and sometimes my key was the item, sometimes it was the delivery note. All the products leave our warehouse based on a delivery note. And in the end, I had this aggregated monthly consumption per item in units, in monetary value for the whole 2022. I used simple things and libraries, NumPy, Pandas, Daytime, and then pdconcat, pdmerge, df.append in order to make the joins or if statements. And then we move to the results where we can see that on the left, we can see that actually around 15% of our total products brings us 80% of revenues. So these are the products uh, for which we spend much time and we want high accuracy and we don't want to run, for example, in stock out situations. We want to share our customers because they are the high runners. And in the contrary, the C products, we don't spend any time, as I said. And what is interesting on the right, the XYZ classification and total value, is that we had in 2022, we had many Z products. It's more than 60%, but it was also the year, I would say, in the transportation of liquids and gases. It could have an impact, as you can imagine. Then, okay, we classified the products. Now what we can do? Now we have a goal, service level goals. What's the percentage of orders which we want to serve in full and without delays? Okay, and in order to achieve these goals, we make decisions based on the ABCXYZ, if we will keep stock or not, if we keep how many units and where, because we have many warehouses across the world. Moreover, ABCXYZ can be used supplementarily for various decisions. It can give us um, a better context in order to realize, as I said before, for what we are talking about. It can help us to reallocate stock from one warehouse to another. And also important, it can help us to align better between production and procurement. If I know, for example, that an item has a constant demand, I can very easily synchronize the purchase of raw materials, the production time, the transportation time, and then have a happy customer. Now, we move to the most interesting part, I would say, for this presentation, the data science learnings. And we start with the basics, things to do upfront. So we start having the end goal in mind, and I'm really fan of the quote, if we can dream it, we can make it. So we start and we say, I want column A, column B, column C, column D, and these are my data sources. These are the relationship between the data sources, and I should also understand how the data is recorded and put myself on the user shoes, because in the end, we make the analysis, we make all the reports for our users to make their lives easier, to make them uh, able to take decisions faster and more accurate. Another learning, it was no assumptions. If something is technically doable, we will find it in our dataset. For example, on the left, we can see that the same item, sometimes it is shipped from the warehouse in kilogram and sometimes in grams. So before adding all the consumption, we should convert everything to the same unit of measure. Moreover, best practices are our best friend because it can secure the accuracy of our report. For example, when we have an if statement, it's always good to have the word other or something in the else statement in order to realize if there are bugs or exceptions which we hadn't noticed. and the performance as well. For example, I used in some cases np.where instead of a for loop and combined with an if statement in order my code to run faster. Sanity checks are very necessary and critical for a good result in every phase of our analysis, because before the analysis with the data cleaning we secure good quality of data, because in data analysis it's garbage in, garbage out. During the analysis we have the validation, early error detection, and I can realize what has gone wrong faster. And last but not least, after the analysis, in order to verify my results, to produce something reliable and valid. Last but not least, I also faced a problem which I have never faced before: how to deal with a non-unique key and to go from table A, where I have taken as a key all the columns except from column D, which I want to be in table B as well, and to end up in column in table C. And now let's summarize for the added value of the project. Okay, before we were making the analysis in Excel. Okay, first of all, it was the accuracy. Excel, it's good, but as you know, it's very, how to say, person dependent. It depends on the person's, on the people's knowledge and motivation, and sometimes people are under pressure. They don't check everything. They make assumptions, some a problem, and in the end, they produce wrong reports, wrong decisions, and they make wrong decisions. So with Python, we don't have this problem, and also the time. Excel takes much time, because imagine that my data was 120K rows, and when you want to filter or to apply some formulas or to find duplicates, for example, it takes much more time. So the end outcome of this slide is that with Python, we make it faster, we keep our people happier, and we make them more efficient because they can produce more in the same time. Some retrospective thoughts now. What could I change? Let's say I could define better the project, who will use it, when, uh, how, what's his knowledge, what systems and softwares does he use, to solve as many problems as possible upfront in order to be totally focused on my project for the previous month, and always to focus on the end outcome, and also to challenge the existing documentation, because there are many times there are inefficiencies and workarounds in Excel which we can solve in Python. Summary of my project: ABCXYZ is a tool to save money and time. And the learnings, okay, as we said, find and follow best practices, be prepared for the Murphy's Law. The code must make the job in the beginning, improvements could follow, and proactivity always pays off. Acknowledgement: Thanos, Dimitris, Ιακωβάκης, Δημήτρης Μουσαδάκος, Σπύρος, Γιώργος, Αλμπέρτος, Δέσποινα, Νίκος, Σοφία Ελπίδα, οποιοδήποτε άλλο instructor τυχαίνει να ξεχνάω, τους άλλους bootcampers, Νάσο, Χριστό, Πάνο, Γιώργο, Αναστάση για το encouragement, and okay, sorry, I switch again to English. Everyone else who I have might forgotten, and you for coming here today in order to watch our presentations.
Dimitris, thank you for the excellent presentation and the great work. Do we have any questions from the audience? Okay, I'll start with one.
Mhm.
From your experience, the whole time you were actually developing the project, what was the difference in time doing the same process in legacy, so in the
Mhm.
Excel, and with Python, like an end product?
Okay,
What
end
was the
product.
end
It
user
depends.
doing before, and
Okay.
what is going to do now with the script?
Mhm. Assuming that the user was making the same sanity checks, because now I make more than before, it would be hours in Excel, and now it's something like 20 minutes, or not even 10 minutes, 15, something like that. But
Okay.
it's, yeah, it's minutes, and the most time it's in order to read the Excel files, which are gigabytes. It's not so complicated, I would say, the methods.
Okay. So, which means that you will run on this dataset a Python script, and it will take up to 5 minutes or 5-10 minutes to run completely, like in
Uh,
one go.
10, 10, because 10 for sure,
Okay.
I
So
would say,
it really
because
needs to
it's
load
you
a
open
lot of
five.
data, lots of data.
Yes, yes. Some Excel sheets are 20 giga, for example, or even more.
Okay. Then another question arises is how you could possibly open this with Excel in the first place. Do you do this with
In the
batches?
first place, easy.
Because
No, no,
you,
no. You just push the button, hit the button, drink coffee, chit chat with the other person next to you, and wait. That's it.
or maybe drink
But
another coffee.
it could open.
Okay.
Yes.
Good to know.
Yes.
Good to know that actually Excel is still a superhero and can at least open these kinds of loads of data.
Yeah, yeah.
Fascinating. Very nice. Okay. Uh, so another question would be, what was the most difficult part during your project?
Uh, I would say the non-unique key, because so far I was
Ah,
living in an ideal world where we had one-to-many or one-to-one relationships. So this was a challenge, and also to understand the problem from a business perspective. For example, before my project, I was thinking that every delivery node, so when we ship units from our warehouse, was connected with only one sales order. But in business, in the real world, it's not true, because imagine that me and Panos live in the same neighborhood. Okay, I'll ship both orders with the same truck, with the same delivery note, and I would say, yeah, this can bring to the data analyst extra job and extra challenges to think about. So I would say the domain knowledge and to really understand.
great. Um, any questions from the audience? Okay. Then, Dimitris, thank you once again for the excellent presentation and
Mhm.
congrats on your project. And I think that it will be put in this project will be put in directly in production next days.
Yes.
Yeah, which is
Yes. Yes.
this is the real value there. So
Hmm.
congrats again, and
Thank
thank you
you.
so much for the lovely presentation.
Thank you.
Okay, now we'll switch also to